we get into this very important concept of converting from mass to moles to atoms or molecules or particles. We had talked about both of these concepts. We talked about moles, we talked about mass. Mass is the quantity we actually measure. Moles is this group of particles, right? So if I have a group of atoms, we can call it a mole of atoms as long as there is 6.02 times 10 to the 23rd atoms in that group. And then of course we can convert from the moles, which is the group of atoms, to the atoms themselves. So it's kind of like asking what unit are you looking for. If I'm looking at this eggs in a carton, right, I can say what is the weight of the eggs. So you just take that and put it on a scale and you'll get a number. So that would be your mass. That's in units of grams. You can also say, well, how many eggs do I have? There's 12. Or you can say there's a dozen. So both a dozen and 12 are correct. So a dozen would just be the group. 12 would be the individual counts of the eggs. Okay, so there's 3 different ways to describe this collection of eggs. The same thing with atoms or particles. There are 3 different ways to describe them. You can use the units of grams, which is just how much the sample weighs. You can use the units of moles, which is just what is the group of atoms, like how many moles, which is how many groups of these atoms do you have. Or you can describe them as individual counts of atoms or molecules or particles. In order for you to do conversion amongst these 3 quantities, you're going to need to follow this path right here. So the moles is what's really useful here. Now, if you want to go from moles to grams, you're going to need to multiply with your molar mass. If you want to go from moles to particles, which means going to these atoms, molecules, later on ions, etc., you're going to multiply also, but in this case with Avogadro's number, which is 6.02 times 10 to the 23rd. That should hopefully make sense because a mole has some mass of items in it, right? And so in order to do that, I'm going to use my molar mass. So if you want to remember what quantity you need to use, just remember that anytime you want to go to mass, which is grams, right? You want to go to mass quantities, you need molar mass. So the same word appears, right? If you want to go to mass, you need molar mass, okay? But if you want to go to particles, then you don't need molar mass, and so the other conversion is just Avogadro's number, okay? So same thing here, you can go from those other quantities to moles. If you want to go from mass to moles, then again, molar mass is needed, but now you're dividing. If you're going to go from atoms or molecules to moles, you also need Avogadro's number, but you're dividing now. So it's the same conversion factor, they're just being either multiply or divide. And again, this multiply or divide really is the idea of using dimensional analysis, as you'll see when I work out the examples here. So if you're having difficulty remembering when to multiply and when to divide, just remember that when you go from moles to something else, you have to multiply. When you go from something else to moles, you have to divide. Okay? And then again, to remember the actual conversion factor, if you're going to mass, then you need molar mass. And then if you're going to particles, then you don't need molar mass. You're going to need Avogadro's number. Okay? Okay, so we just saw that discussion about converting from mass to moles and moles to particles. You might not remember whether to multiply or divide. So the easy way to remember this is every time you go from moles to something else, you multiply. And every time you go to moles, you divide. So we're going to do all these 3 examples here of conversion of mass to moles, moles to particles, as well as from moles all the way to grams. I'm going to start the first one where it says convert 12.5 grams of oxygen gas to moles. So you want to remember that some of these elements that we had discussed before are diatomic elements, meaning that they're formed by 2 of the same atoms combining together, joined by a covalent bond. So oxygen is one of those diatomic elements, so the formula is actually O2. Now, to go from grams to moles, you have to divide. Because grams is a unit of mass, you just remember that that would mean you need molar mass to help you do that conversion. So the mathematical process is this. You take the 12.5 grams and you divide by the molar mass of oxygen gas. Remember, that's O2. So you would go to your periodic table and search up oxygen. Each oxygen is 16. Since you have 2 oxygens, it's going to be 16 times 2 to give you 32. That's what I have there. And so 12.5 divided by 32 is the same as 12.5 grams times 1 mole over 32, right? I point that out because it highlights that dimensional analysis component of this problem, which is that you're trying to cancel the same units so you can get to moles. In this case, your final answer should be 0.391 moles with 3 significant figures. The second problem asks you to convert 0.234 moles of nitrogen gas to molecules. I put the correct formula there, and two, in the problem itself, it just says nitrogen gas. So again, another time for you to remember that nitrogen is a diatomic molecule. Now we're going from moles to something else. Every time you do that, you want to multiply. There's no mass here, so the other conversion factor you need to remember is what we call Avogadro's number, which is 6.02 times 10 to the 23rd. So all you need to do is take that 0.234 mole and multiply it by Avogadro's number. Again, I want to highlight the dimensional analysis component here. The moles cancel. You're left with units of molecules. And if you multiply that out, you get 1.41 times 10 to the 23rd and 2 molecules. The last problem is the most difficult one. It's asking you to convert from molecules all the way to grams. So you have to think about a couple of steps. First off, you can't go directly from molecules to grams. You always have to go through moles. So moles is your bridge in between grams and molecules. So in this case, we have to take it from molecules to moles first. Remember, if you're going to moles, you divide by Avogadro's number. Once you have the moles, you're trying to go from moles to grams. Now you're dealing with mass, so molar mass comes into play. Anytime you move away from moles to something else, you multiply, so you're going to multiply with molar mass to get to grams. Those are the 2 steps we need to do. Start with the division. Here I take the molecules and I divide by Avogadro's number and I get moles. After I get moles, I multiply by the molar mass, which I calculated using the periodic table. And that in the end gives me 0.186 grams. Again, I want to highlight the dimensional analysis part of this. The molecules would cancel here, one in the numerator, the other one in the denominator. And then the moles here would also cancel, leaving you with the unit of grams at the end.